I'm Sabina Amelia Hansa.
I'm 17 and I'm from Islamic State Senior High School, Malang City, Indonesia. 2020 was a year full of surprises, where the outbreak of COVID happened and the world came to a standstill. People are fighting and struggling for a living, where the economic condition took a severe hit and social interactions were kept to bare minimum. People lost friends, family, classmates, and lovers due to the pandemic, and one of them was my best friend. She fought against the virus for 2 weeks in self-quarantine and was no longer diagnosed with COVID-19. But unfortunately, she lost her life not long after, caused by the long-term health consequences of the virus. Most people recover completely from COVID-19, but for some, the poorly understood condition known as long COVID could last for months, even years, and no one has yet to know for sure. My best friend were not the only victim. Studies from Indonesian universities and Persahabatan Hospital state that 63.5% of the 463 COVID-19 survivors experienced long COVID, with a number that will increase if projected on the patient population in Indonesia. IUSA in 2021 also proved that 4 out of 10 post-COVID patients were declared dead with the level of D-dimer up to 163 nanograms per milliliter. D-dimer itself is a fibrin-degeneration product that is useful for detecting abnormal clot formation or thrombotic events and for assessing the presence of clot breakdown or fibrinolytic processes. The level of D-dimer above 500 nanogram per milliliter is related to the high mortality risks in the post-COVID-19 patients. However, D-dimer level test is expensive, takes a long time, and also needs blood plasma as a sample, which must be carried out by experts and requires a patient to go to the hospital or clinics by testing using ELISA kit and measure it by ELISA reader. Fortunately, in 2015, Olivia Hallisey succeeded in creating temperature-independent strips, adopting ELISA kit method and lateral flow assay using silk fiber materials. So, with Malang City Research Olympia team, I innovated D-dimer strip, which is able to utilize urine and saliva as non-invasive samples for D-dimer tests that can be done everywhere, every time, and by everyone. Silica is also added to make a longer shelf time because of its ability to protect drug from extreme environments. And machine learning is also developed and integrated in mobile application for easy test classifications. Therefore, I present my research with the title of D-dimer levels in urine and human saliva samples toward COVID-19 patients in recovery phase for making D-dimer levels rapid tests using machine learning. The goal is to determine the method of making a D-dimer strip for testing the levels of D-dimer using saliva and urine samples and classify them using machine learning-based applications. The research was conducted from June until November 2021, which was carried out in Integrated Science Lab, Malang City, TIMUR Clinic, Laboratory, and Sheikh Anwar Hospital in Malang City in several steps. And it begins with collecting post-COVID respondents and sample with Dr. Tatit in Sheikh Anwar Hospital, doing the fatigue assessment scale and STS test for each respondent. And secondly, I also prepare D-dimer strip for the sample testing combinations, and thirdly, determining the machine learning model for developing the applications. Next is a comparison of blood, saliva, and urine samples tested using an ELISA kit and measured by ELISA reader in TIMUR Clinic Laboratory, which as the gold standard is carried out. The test of D-dimer levels in saliva and urine was done using our reagent ELISA from Bioassay Technology Laboratory and measured by ELISA reader with the samples from 10 healthy and 10 post-COVID respondents. The following is a standard absorbance curve used, and with the absorbance values and D-dimer concentration in each patient as follows. With a graph of the comparison of saliva, urine, and blood from post-COVID respondents as shown on the slide. As the result, 6 from 10 post-COVID-19 respondents have the same characteristics in saliva, urine, and blood testing, which tend to be high, although patients have been declared negative from COVID. And it can be concluded that saliva and urine can be used as non-invasive samples for substitute blood plasma in testing D-dimer levels, which the concentration can be differentiated from color intensity in the D-dimer test strip. Next is the developing the D-dimer strip that begins with purifying the sick fibroin and manufacturing the test strip. After several trials and errors, we get the best method to produce sick fibroin. With the first step is purification, which begins with the gumming of silkworm cocoons with sodium carbonate for 2 times in an hour, then dissolution using 9.3 mol of lithium bromide and incubated for 20 minutes at 70 degrees Celsius. Next is dialysis using dialysis tubing 3,500 per size with exponential time multiplies. And lastly, 2 times centrifugations at 9000 rpm at 40 degrees Celsius for 20 minutes, then followed by at the binary silica, where the binary silica stock was actually created in the previous year's research. And the next is the insertions of reagents and testing of D-dimer strips, where the reagents used were primary, secondary, and MBT-BCIP antibodies, and dripped 20 microliter on each different arms. The test was carried out by dripping 500 microliter of PBS into the end of the sleeve and allowing it to flow to the center. And positive indications are indicated by a color changing to yellow and negative to the blue caused by the antigen. And the use of PBS here functions as a solvent that dissolves antigens because the volume of antigen given is very small. And then, the SAM test was carried out to see the characteristics of the samples and can be concluded that the bionano-silica particles are able to bind to the citriboin to wrap the reagent so that it can slow down the oxidation, which can damage the reagent. This D-dimer strip has the following mechanism of actions, where the color change from colorless to yellow occurs due to the oxidation process of TMB, which releases 2 electrons and is accepted by hydrogen peroxide to produce products in the form of oxidized TMB and water. And we compare the strip shelf life comparison and find out that the D-dimer strip using lithium bromide and bionano-silica can last up to 28 days without refrigeration. Machine learning with convolutional neural network method, which uses Python programming language, is also developed using image data from the strip test results. 1,000 samples divided into 80% for data training and 20% for data testing. Image is taken from 20 strip test results with variety of image capturing with various angles, lighting variations, and also the camera quality. And data is uploaded based on class, which is high D-dimer level class and normal D-dimer level class, with accuracy values and conversion calculation metrics is up to 90%. In conclusions, saliva and urine can be used as a non-invasive sample that facilitates testing of D-dimer levels and successfully tested by a strip that I designed using 3-arm strip and made with filter paper with the addition of reagents ELISA by BioAssa Technology Laboratory, where the positive color image is yellow and the darker of the yellow color product marks higher D-dimer level and could be done everywhere, every time, and by everyone. The result can be classified easily with the camera using machine learning based mobile applications that are made. And this is how D-dimer strip apps works. Beloved best friend, to all people who suffer during this pandemic, while witnessing the confusions, I committed to take a role in responding to this public health emergency and continue to encourage the development of better tests that will enable us to address the challenges.